Hello everyone, welcome back. So this is our lesson number 5 of the chapter Carbon and its compounds. So here first we will study about close chain hydrocarbons and alkyl group. So here hydrocarbons are separated into two types. One is open chain hydrocarbons and the other one is close chain or ring cyclic hydrocarbon. So we'll see the example of close chain hydrocarbon. See the first example, cyclohexane. And cyclohexane has the chemical formula C6H12. Alright, now see the structure of cyclohexane. So from the structure you can see that there are no CH3 endings because it forms a ring. See the structure, it forms a ring, right? So it has no CH3 ending. Instead, each carbon is connected to a CH2. So every carbon is connected to CH2, right? Here one carbon and two hydrogen atoms. Alright, now next see the second example, benzene. So benzene has chemical formula C6H6. So see the structure of benzene. Since every carbon has only 3 bonds, hence every carbon has one free valence electron. So here X represents the valence electrons. Is that clear? Okay, so see here in benzene it has 6 hydrogen atoms and 6 carbon atoms. So the structure has a 6 carbon ring which is represented by a hexagon and it includes 3 double bonds. So see the double bonds, it includes 3 double bonds. So clear everyone? Alright. Next we will study about the first 10 members of the alkane family. Methane, first is methane, second is ethane, third is propane, fourth is butane, fifth is pentane, sixth is hexane, seventh is heptane, eighth is octane, 9 is nonane and the last one is decane. Alright. So this is the alkane family. First 10 members of the alkane family. Users need to remember this chemical formula and the name. Alright. Now move to the next slide. Now let us consider the first 4 members of the alkane family. So we have to consider here the first 4 members of the alkane family. This methane, ethane, propane and butane. Okay. See here the general formula CnH2n plus 2. So this is the general formula for alkane. Okay. And here the name of the compound is methane, ethane, propane and butane. The general formula and their chemical formula is also given. CH4 for methane, C2H6 is for ethane, C3H8 propane and C4H10 is butane. Now let us see the structure for methane. Alright, so see the structure of methane now. See here 1 carbon atom and 4 hydrogen atom. So this is the structure of methane. Here when 1 hydrogen atom is removed, we are left with CH3. So can you see when 1 hydrogen atom is removed, we are now left with only 3 hydrogen atoms. So it is your CH3. So on removal of 1 hydrogen atom from alkane, we get alkyl group. So it means if CH4 is methane, then CH3 is methyl group. So here see, on removal of 1 hydrogen atom from the alkane, we call it alkyl group. So now alkyl group means an alkane where missing 1 hydrogen. Is that clear? So alkyl group means in an alkane missing 1 hydrogen. So here when 4 hydrogen atoms are present, it was methane, but here only 3 hydrogen atoms are present. So it is now methyl group. Clear everyone? Okay, good. Now similarly the structure for ethane C2H6 is this one. See 2 carbon atoms and 6 hydrogen atoms. Here on removal of one hydrogen atom from C2H6, that is ethane, we get C2H5, right? Only 2 carbon atoms are left already, and here only 5 are left now. 1, 2, 3, 4, 5 hydrogen atoms are left. Therefore, it is your ethyl group. Is that clear? Okay. Now see the alkyl group, and the general formula is, for methyl it is CH3 because one hydrogen is missing. Second is ethyl, C2H5. Here also one hydrogen atom is missing. Third is propyl, C3H7. Here should be C3H8, right, for propane, but since it is alkyl group, so it is propyl. And C4H9 is butyl. Am I clear, everyone? Okay. Now, what will be the general formula for alkyl group? So, the general formula of alkane is CnH2n plus 2. We already know this, right? Now, since alkyl group has one hydrogen atom less as compared to the corresponding alkane, so CnH2n plus 2 minus 1 is needed for the general formula of alkyl group. Why minus 1 is needed in the formula? Because one hydrogen atom is missing. So the general formula for alkyl group is CnH2n plus 1. Is that clear? Alright. So the general formula is CnH2n plus 1. Now here R, it represents the alkyl group. Okay. Now see the alkyl group which will be represented by R. CH3 methyl, C2H5 ethyl, then propyl, C3H7 and butyl, C4H9. Now let us consider the methyl group. Okay, on removal of one hydrogen atom from methane, carbon becomes unstable. Okay, so on removal of one hydrogen atom from methane, the carbon atoms, this carbon becomes unstable. The hydrogen atom removed can be replaced by OH group. To make it stable, we will replace it by OH group. So in organic chemistry, OH group represents a group of compounds called alcohols. We will further study about these alcohols, but as of now, just keep this point in mind. So in organic chemistry, OH group represents a group of compounds called alcohols. So here R, this is your alkyl group, right? So it is represented by R, and here OH, that is your alcohol group. As I told you, see here compounds called alcohols. So methyl alcohol, the formula is CH3OH. Clear, everyone? So the compound name is methyl alcohol. Similarly, C2H5OH ethyl alcohol, C3H7OH propyl alcohol, and C4H9OH is your butyl alcohol. Okay, next is we will consider the methyl group. So see, this is the structure for methyl. Actually it was methane, but there is a removal of one hydrogen atom. So again the carbon becomes unstable. Now the hydrogen atom removed can be replaced by chlorine group. So Cl means it is the chlorine group. So here in place of hydrogen we will place chlorine. So again this alkyl group is represented by R here, and this is chlorine. So this is your chloride. And the compound name is methyl chloride. Methyl is coming from here, this portion, and this chloride is coming from this portion. Alright, so the chemical formula is CH3Cl. Similarly, C2H5Cl, it is ethyl chloride. C3H7Cl, it is your propyl chloride. And C4H9Cl, it is your butyl chloride. Alright. Okay guys, next we will study about the functional group. Now let us study methane and methyl alcohol. So first is methane. This is the structure for methane. From the structure of methane, if one hydrogen atom is removed and substituted by OH, the compound now becomes, name the compound now. It will become methyl alcohol. So this hydrogen atom is being substituted by OH group. So OH group is your alcohol group. So it is your methyl alcohol. Methyl is coming from this portion. Now, are the two compounds same? This methane and methyl alcohol, are the two compounds same? Can you guess it is same or not? Definitely not. Okay, now let's see the reason why it is not same. See, methane is a gas. So usually we can find methane in cow dung. Okay, the gas present in cow dung is methane. So it is a gas. Whereas methyl alcohol is a liquid. So it is completely a different state. One is gas, methane is gas, and methyl alcohol, it is a liquid. So they are not same. Since OH is determining the properties of methyl alcohol, it is called as the functional group. Is that clear? Alright, again see this. Since OH is determining the properties of methyl alcohol, it is called as the functional group. Now the functional group in organic compounds. Now first see the definition for functional group. The atom or group of atoms present in the molecule which determines characteristic property of organic compounds. It is called functional group. So it's a very good definition given here. Please note it down. Here means the atom or group of atoms that present in a molecule which determines the characteristics property of a organic compounds. So those are your functional group. Alright, now see the functional group. First is compound. Then the general formula R equal to CnH2n plus 1, the functional group, and examples. Okay, so R here it is the alkyl group. It represents the alkyl group as I already told you. Alright, since it is alcohol, so it is OH. Now, example is here functional group OH. So, one example is your methyl alcohol. Another one is C2H5OH. Okay, name the compound C2H5OH. It is your ethyl alcohol. Alright. Now second compound is carboxylic acid. So this is your functional group. See, C double bond O and here single bond OH. So the general formula is RCOOH. Alright, here again R represents the alkyl group. Now the two examples, CH2COOH. It is your acetic acid. Next compound is aldehydes. So it has the functional group, this one. C double bond O and C single bond H. And the general formula is RCHO. R is the alkyl group and CHO is the aldehyde group. So the one example is CH3CHO, it is acetaldehyde. See the suffix? Since CHO group is present, so it is your suffix will be aldehyde. Acetaldehyde. The compound name is acetaldehyde. The last one is ketones. So this is the functional group for ketone. This is the functional group for ketone. C double bond O. Now okay, see here. Here one R single R is present and the other one is R dash. So here R and R dash both can be same or different alkyl group. Okay. So the example of ketones are CH3 CO CH3, that is acetone, or dimethyl ketone. Okay students, so we are done for today. Now those who have not yet downloaded our app Nakhyatra, you can download it from the link given in the description box. So there you can do the live classes, you can even watch the recorded classes, and to clear your doubts you can interact with me directly. Okay, thank you.